While the next presenter sets up his computer, I will try and introduce him. I've known him a long time. In fact, I've known him since before he started working at Dialog as it is now. He's not as clever as he thinks he is. He's embarrassed me on more than one occasion, but to be fair, I've done the same to him. What else can I say? Yeah, it's not as fun. His jokes generally are awful, so if you ignore them, then try and do that. They're likely to be repeated, so you're going to have to keep ignoring them. He's arrogant. He's come up with a theory. He's arrogant enough to think that it's a theory about everything. I'll leave it up to you to decide how complete that theory is. And he can't remember his password. Okay. So thank you, John. Right, okay, we've done that. So, hello, thank you for coming. I'm going to talk about my big toe. I'm already regretting the name, the big toe. I wanted to come up with foot jokes. I couldn't come up with it with enough to make it funny, so please excuse me. But over the past years, I've been concerned about the growth of a number of things in the interpreter, particularly things that are about providing information about your program or the environment or the development environment. Generally, the language is good. We're putting in primitives and operators and stuff, and your program runs well. But there's too many different ways of interrogating bits of the system to find out what's going on. And we keep adding new ways of doing this. Recently, we've added I-beams, which is a fairly bizarre way of us putting in some functionality that we're not completely confident about, or isn't really languagey enough to warrant a primitive, or isn't really a well-baked enough idea to warrant to being a system function, and so on. In version 13, we had no I-beams. In version 18, an approximate count is 163 different I-beam functions. Now, some of those you know about. Okay, some of those are public. Some of those you don't know about. We keep them very quietly for use inside, mainly because they're for either QAing or debugging or testing. But the whole process of having an I-beam as a way of getting information about the system is a little bit clunky, and it's not really very maintainable. Similarly, going back for, 20 years we've had QuadWC, we had mechanisms inside QuadWC to get information about your machine or about the environment or about things like, for example, what version of the interpreter am I running? Get some environment variables, integrate with Windows services and so on. And this is a combination of properties on QuadSE, properties on hash, methods on QuadSE, and it's all a bit of a mess. There's no necessarily any great consistency in how you might access that information. And then there's a bunch of system functions or variables, all of which exist to give you information about your program. You generally don't use most of these when your program's running. I mean, there are exceptions to that, obviously. But generally, these are things that you use during development or during writing documentation for your application. They're not really languagey things, and that syntax for these is different. Some of them take string arguments, numeric arguments. And again, it's all a little bit sort of inconsistent. Oh, and then more recently, we've added this thing called variant, which basically means we can add an extra level of complexity onto all of these things, which are perhaps already too complicated anyway. So there's too many ways of getting information about your program. We recently, we were aware that this was a problem, and there is a project that we have in-house for a thing called quad metadata, which is an attempt to take all of these things that return information about your program and wrap them up into a single consistent mechanism. And in fact, quad metadata itself is actually just a placeholder to provide a unified mechanism, not necessarily a system function. Okay, so we've been aware for some time. I say recently, in fact, this says we'll think about this during 13.1 so that we can get it in schedule for version 14. Clearly, that didn't happen. Interesting, though, thing down here, of course, is a lot of these functions take the names of things as arguments. And there's a thing here that says, in many cases, it would be nice if we could figure things out based from values rather than from the names of things. So we'll bear that in mind as we go through looking at my toe. Doesn't sound right. Something else we've talked about recently is quad features, which is again another system function perhaps, or maybe an I-beam, to retrieve information about your running environment, whether it's environment variables or how much memory is on the machine or how many CPUs are on the machine. And it's, or what version of .NET you've got, or what the temporary directory is, or what path separators are, or what your line endings are in text files and so on. And quad metadata, quad features, quad AT, quad this. There's too much stuff we want to give you and no great consistency in how we might do that. So I'm concerned about all sorts of things. And then we start thinking about, well, okay, maybe I want to get hold of environment variables, or maybe I want to integrate tightly with the IDE. Maybe I want to, where are we? Maybe I want to talk better with RIDE. Maybe I want to talk to something else that I haven't thought about. Maybe there's this idea that, there's everything out there that we want to be able to get information from. And it would be nice if we had a theory that covered everything that we want to be able to talk to. And as John said earlier, he likes to talk about himself in the third person. He's arrogant enough to say, this is my theory and I own it. Before we talk about everything, let's talk about something. And this is a slightly artificial example of the sort of thing that I'm talking about. But there's been a lot of discussion over the years about how do we find out whether a function is a dphone or a tradphone or something else. I don't know why you want to know, but there's been, there's stuff on the website about it. We'll see that in a moment. But, as it turns out, we implemented an extension to quad NC to tell you if a function was a dphone. But we could have done it with quad AT. We could have done it with an I-beam. There's, as I say, a bunch of creative solutions to the question on the website. Or we could do something else. Now, I sort of quite like this idea of doing something else. Okay. I sort of would like to be able to type something like that. Let's ask the function itself what it is. Let's ask it for information about itself. But of course, this is going to be a value error because we've overloaded the dot. In that case, it thinks it's an inner product. Okay. So we can't use a dot. And dots are also used for numbers. The dot isn't something that we can put as a syntax after a dphone to do it, or after a function or after a name to do anything. It was Jeff, actually, many years ago when we first introduced his namespace references, where he said we probably shouldn't use dot for going in and out of namespaces because, dot's already overloaded more times than it should be. And I hesitate to say that he was right, but I'll hesitate and then I'll say that he was right. So what I want to introduce is a new sort of dot, a super dot, a bullet, a blob, call it what you like, but something that we can apply after something, okay, specifically maybe after a function and say, okay, is this thing a dphone? If you can think of this as a way of accessing an internal object model of this thing fun, and one of the elements in that internal object model is a property, if you like, or a value that tells us whether or not this thing is a dphone. And if we take then this bullet, this blob, I'm going to use those words interchangeably, then in theory we could put anything to its left and we could put something else to its right. Now I'm no expert in set theory, but I reckon if I can take anything and add something to it, that pretty much means I can do everything that I want. So that's the theory. The theory is, let's have this new syntax. Think of it initially like a dot, but there are some significant differences, which we will see, that allows us to do a bunch of stuff in hopefully a consistent fashion. Now, before we come to the demo, because after this it's all going to be demo, I just need to make a couple of apologies. Now, some of you will have seen some of this demo before. Okay, but the good news for you people is that there's actually a bunch of stuff which is new that you won't have seen before. Now, there are also a bunch of Dialog employees in the room. The same is true for you, but the news isn't necessarily good news that there's a bunch of stuff that you haven't seen before. There'll be surprises ahead, perhaps. Now, there should be a third slide here, which basically says there are some Dialog employers in the room. And then the bad news is for me that I'm about to show them for the first time a bunch of stuff that they've not seen before. So, let's come to the demo portion of the presentation, and we'll see what you think about the theory of everything, and we'll see if I can explain it in a way that makes sense. So, I'm going to come to my APL session. Now, you've seen a lot of people at Dialog do demos where they sit and they hit F12, or Mike Morton was clicking on the next button up there. That's too much like hard work. I've got my clicker. I can use my clicker now to execute expressions into my session. And I've already made a mistake. Would you look at that? Wow, hold on, let me just, hold on, let me back up a little bit. Oh, man. I'll tell you what we'll do, hold on. You see nothing, right? I'm not here. Let's just start again. I'll maximize that. Right, so I can just click my clicker now, and things that I would otherwise have had lots of difficulty in typing are going to appear as if by magic at the bottom of the session. So I should now not have to get up and go back to my laptop until either I make a horrendous mistake, like I just did, or I'm intentionally going to have to interact with something. Now, I am using a different clicker to the one that I'm used to using, so things may at any point go horribly wrong, as indeed they just did. But actually, the first thing I want to do now is I want to just get rid of the session log. I want to start off with a nice, clean session log. So what I'm going to do here is I'm going to emulate a select event on the appropriate menu item that does new session new. So we'll do that. And now I have to stand up and I have to go over here. And I have to press the OK button. But what I'm doing there is, on the session here, there's a session at session.mb.log.new, and I've emulated a click on there. OK, right. So, Jay pointed out yesterday that a bunch of these things we're doing are in the time scale of version 18, but there's no guarantee that any of this stuff is actually going to be in version 18. OK? It's just convenient for me that I have a version of the interpreter that I can do this in. You see, right, here we go. Okay, so I'm going to start in a clear workspace. I'm going to set my quad IO and my quad ML to 1 and 2. Okay, so here's a defun. It just duplicates its argument, and let's look at it as defun. Okay, so there's all of this stuff on the interwebs where we've been through, where we've talked about different ways of finding out whether something is a defun or not. And then right at the bottom, there's a little thing that says, oh, you can actually use quad NC, and if the modulus of the result has got a 0.2 in it, then it's likely a defun. So that's a bit clunky, but it sort of works. 3.2 for this defun. So the test for are you a defun is pretty much that. But with the, and of course, as I say, this is a value error because it thinks it's an inner product, and that thing called isDefun doesn't exist in the current namespace. But let's bring in the magic bullet, the blob. Okay, so with the blob, we can apply that to the defun and ask it whether it's a defun. And all things being equal, it comes back and says, ooh, yes, I am. So this is new syntax. Think of it like a dot, but as opposed to a dot that goes into your sort of APL namespace hierarchy, it's a dot that goes into some internal object model that the interpreter knows about, where we can extract information about things that are in the workspace. So that's the original expression. Something else that we might want to do, it might be a little bit too specific to have something that says, I'm a defun. Maybe we want to remove the quotes and remove the need for the end close and still have a syntactically simple expression using the blob to give me the name class of the thing to the left of the blob. So that works. Let's create a similar, a tradfun that does the same thing. It duplicates its argument. This is what's a great function. Skulls taught me this one. Dupe, 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 dupe. They say never use the same variable, the same name for the different variables, but where's the fun in that? So we can use that function. And of course, dupe is not a defun. Okay, dupe is a tradfun. Okay. Now, because we're APL and because this blob is a little bit like a dot, we can use parentheses after it and we can extract multiple pieces of information at the same time. What's the name class of dupe? Okay, it's 3.1. It's a tradfun, not a defun. These extra lines are appearing because I'm making mistakes with the button. Hopefully it's not going to go horribly wrong. Right, so quad AT is one of these system functions which returns metadata, if you like, about a function. And this tells us whether or not the function returns a result, takes a left argument, something else, the timestamp on it, and who fixed it. But again, we can abstract some of that information that we would have used quad AT for and add it into our internal object model. So we could say, well, who was the person that edited dupe? And we can join all of those things together and query multiple bits of metadata from the function dupe using the blob and access multiple elements of that internal object model. Do the same thing with the defun, of course. Whoa! Okay, what's happened here is that multiple lines have executed all at the same time. But hopefully I can blag my way through this. But the point I'm saying here is if you look at this expression, which I'm now not going to be able to execute, what we've got here is we've got a combination of the information that would be returned by quad AT and some information that would have been returned by quad NC, okay, and some new thing, which are now all being returned in a consistent manner. Okay, we don't need to understand what quad AT is, we don't need to understand what quad NC does, we don't even need to know that they exist anymore. We can have a consistent syntax to access all the metadata that we might want to have for, in this case, this function. And that satisfies the criteria that we have for quad metadata, which is, in many cases, it would be nice to extract information for a value rather than a name. This isn't in quotes, so it's a value. It is the defun rather than the name of the defun. Hopefully, when I press this button, that'll go away. When I press that button, we'll execute that, but because it's multiple lines, and hopefully, right, so now, if we want to provide more metadata to you, stuff that doesn't already exist, like, for example, say we wanted to give you information about the parameters that a function took. Okay, you know, we can have parentheses now around the right argument to a function, and you can have multiple names. Maybe it would be nice if there was a way of retrieving that programmatically. Now we can add it to our internal object model, maybe with the name parameters, and we don't need to extend quad AT in a way that might be a breaking change. We don't need to have a new system function or a new variable. We've got this extensible model that we can add names to, reasonably lightweight. You have no new functions to learn, there's just a new entry in the documentation for the object model for a particular function or a particular type of thing. Of course, I haven't implemented these three, which is why we get a value error when we try and reference them with the blob. A couple of points that are worth noting. If we have a niladic function, we can apply the blob to the niladic function. It's important to note that at this point we don't invoke the niladic function. Okay, the blob is happening on the reference of the value of the symbol. So we're not running nil at that point. We're just interrogating it and returning information about it. And again, we can do all of this sort of stuff on our niladic function as well. If we try and reference something that doesn't exist, we'll get a value error. If we try and add a new name to that internal object model, then we'll also get a value error. The list of names that are valid in these things are nailed down, they're locked down. We can't introduce new names. Number of reasons for that. Primarily, it's performance. If we know that all of the symbol tables for each of these objects, which is essentially what they are the same, then we don't need to keep recreating them. The memory management overhead is less. Things will be quicker. And quick is good. If we have a defun which is an idiom, then oh, yeah, okay. So this is just a defun that just returns its argument. Okay. Okay, this is a defun. It's also an idiom. Maybe we want to know that something's an idiom or not. So I said in the blob, wouldn't it be good if we could apply the blob to anything on the left and we could put something else on the right? So we could apply the blob to a primitive. Is iota a defun? No, it isn't. It's a primitive. What's its name class? It's 3.3. Okay. If we do function assignment to that, then iota is also a primitive. So, you know, the model extends through regardless of whether we've done an assignment or whether we've done anything like that. But something else we can do is now we can find out, well, what's the help for iota? Okay, we don't need to put the iota in quotes. We don't need to use an I-beam. We have an I-beam, currently 911 I-beam. It's a joke. It's help. It's American. It's the phone number for American police. So it's what's the help for this. But of course we can, and then we can use the blob in a regular APL expression. We can take the result of that and do all the normal sorts of stuff with it. But I said that, wouldn't it be great? This is a theory of everything. Here's a train. Trains in the interpreter are basically stored as combinations of, let's just see what it looks like. So this is a train that adds, divides, and multiplies its two arguments and concatenates the results together. That's switch boxing on. This is what the train looks like. In the way we implement these things internally is that basically trains are comprised of something, of a triplet of things, something to the left. Okay, so the left-hand side of this train is plus, something in the middle. So this train has got a comma in the middle and something on the right. The thing on the right is divide, comma, times. And the thing on the right has got a thing on its left, and the thing on the right's got a thing in its middle, and the thing on the right has got a thing on its right. And in fact, we can invoke the thing on its right as a function and just do the multiplication. Okay, so here we've got a way, again, we've not introduced any new functions. We're using the syntax, we're using the blob, we're using the theory of everything to do something that you've not been able to do before in this case. In fact, we have an I-beam that goes through and does this sort of stuff, but I-beams are not necessarily always the best way of doing something. But hopefully you can see there's a consistent pattern emerging about how we might find out stuff about stuff. I'm going to have to move on. And so there's some more examples of trains here where we just got a value for increment and it's doing the same sort of thing. Okay, so let's switch boxing off. So again, it's a theory of everything. We can apply the blob to literals. Oh, no, you see, it's gone wrong. Let's take 42. Okay, what's the quad size of level? Well, it's 16. But now we can say, well, what's the size of 42? We don't need a name. Okay, if we want to know what the DR of 42 is, we can just say, what's the DR of 42? And we can put any complex, what are we doing? I mean, again, these are just more examples of the same thing. Okay, we can have anything we like to the left of the dot and find out what its data representation is. Or we could find out what its data representation is and how much workspace it is using. Even, a literal character vector, for example. Oh, don't do that. But it's a theory of everything. Okay, there's more. More is everything. Everything has got more in it than just defuns and 42s. Here's a line of code that we use quadfix to fix a class from a file. So what we've got here is we have something of class 9. We can apply our blob to that. We can find out information about the script whence it came. And this is an expression that has returned actually an object, but it's an object that's within the internal object model. So we can say, okay, well, what file did you come from? And what is your start position and end position within that file? This is stuff that we can currently do with I-beams, but I-beams are not good, they're not portable, they're not consistent. Well, they're portable, but they're not consistent. Let's edit our chart wizard. Let's move the edit window a little bit. What's the name class of chartwizard.util? It's 9. Let's find out where it's defined in the script. Well, it begins on line 26, and if we scroll the edit window, we can see that indeed on line 26, that's where chartwizard.util is defined within that script. So again, everything, all of that information that you wanted to know, there's a consistent model now, a consistent way of getting at that metadata. Here we've got a thing called getDialog version, so we can run that function. We can ask that function, where is it defined within the script, and we can see that it's on line 45 and it finishes, or it goes from line 45 to 50, although 50 is the beginning of the next thing. If we change space into chartwizard.util, okay, there it is. We can do the same thing. Right, so here's an important thing. If we were inside a namespace, and we don't provide anything to the left of the blob, then we are accessing the metadata for the current namespace. So if we find out what the script is of where we currently are, then we get all the same information. Let's come back to the root. The root has got no script, so it returns quad null. So features. Okay, so let's talk about features. Remember, I had a big list of things that I wanted to return. So there are some things that are so useful you want to be able to access them from anywhere. Okay, they're not necessarily metadata about the namespace that you're currently in, but it's information about the general environment that you're running your program in. And features is one of those things. So regardless of what namespace we're in, we can use the blob with nothing to the left to get the features of the currently running interpreter. So if we do run that, we get something back that looks like it's an object. We can say, are you a classic interpreter? We can say, are you a 32 or a 64-bit interpreter? We can say, what's the interpreter version here as a character vector, rather than the fairly nasty, give me back a nested array, which I then have to parse the dots out of. If we want to interrogate the system, we can do that, get an object back from the internal object model. What's the temporary directory on this system? It's useful to know that sometimes. What's the path separator on this system? I'm on Windows, it's a semicolon. What separates directories? On Windows, it's a backslash. That may be important to us. What's the name of my operating system? Well, I'm running on Windows. What's my end of line stuff? Okay, so on a Windows operating system, the end of line markers are typically characters 13 and 10. So we can interrogate the operating system on which we are running using the same syntax that we've been using to find out whether something is a defun or find out who last edited a thing. It's cross-platform. I haven't got time to go into that now. Settings is another thing. You want to find out what's my max was. Okay, so settings is an object that has multiple values associated with it, and we can use indexing to get those values out. And my current setting for max was as set in my registry is 256 megabytes. Where in my registry is it set? Well, it's set there. If I want to get multiple things, I can index multiple things, I can mix that, and I can find out what's my max was, where's my Dialog installed, and what's my salt command folder. Right, so you get the idea, all of this sort of stuff. We can get information about the workspace. Okay, there's my max was. If I divide that by, that's in bytes, if I divide it by, if I could find divide, it would be easy, wouldn't it? 1024, that's in megabytes, divided again. There's, there's our 256 megabytes that we saw via the other route before. And we can interrogate how many workspace compactions have there been and so on. I'm going to shoot through some of these because I think we're getting the idea about what's going on. Because what I wanted to do now is just move on to more things that are in everything. Let's just, don't care about this anymore, don't care about any of that. I'm just going to shoot through that because I'm not going to have time. I don't care about that. Actually, maybe I do care about that. Let's just have a look. Okay, yeah, okay, I'm going to have to rock through, but we can also access elements of the environment variables in the same way. Okay, what's the username, what's the name of the computer? That's a lot slicker than the +2 quad enq quote dot. Run this method on the root object to ask for environment variables. This, I think, is much slicker than that. This is a confusing syntax. You sort of have to know about this. This is not a surprise given all of the things that we've seen in the previous 10 or 15 minutes. And there's all sorts of things that we can do with the environment, but we're not going to do them now. We can set environment variables and we can retrieve them, of course. So, but it's a theory of everything. Where are we going next? Right, so here, remember that mistake I made at the beginning? It wasn't a mistake. What I did was, I sent a select event to quadac.mb.log.new, and what happened is a message box popped up. Okay. Now, with a bit of presentation magic, I can make the message box go away just with a click, nice and easy. I don't have to walk anymore, but that's presentation magic. The problem with this is that if that menu item doesn't exist on my in my session file, because maybe you've moved it around or you've changed the language, it's not called out anymore, this would have generated an error. Okay. Now, I don't know much. I know nothing about nothing, but I know a little bit about everything. And I know that if I've got an integrated development environment, that is part of everything. So using this theory, we can interact. Maybe I should go back to pressing F12. It's worked fine when I've been doing this. Okay, so we've got an IDE. So inside our object model for our IDE, we might have access to the log. Okay, we might be able to get the lines that are in our log. And I don't want all of them, I just want the first 10. And we want to mix those. Oh, we don't want to do that. Anyway, so I can retrieve my entire log. But more importantly, I can now programmatically, in a consistent fashion, clear my log, okay? I don't need new syntax. I don't need a new property on anything. I'm just using the blob and the bullet in the same way that I've been using it now for 20 minutes, thinking the 20 minutes I thought was only going to take 10 minutes, which is now I'm desperately running out of time. So, we can do that again. Right, so let's come to some more demos. And man. So here's some HTML. Let's edit that HTML. Let's look at something else in the IDE. Okay, the IDE knows about editors. Okay, look, there's an editor. Let's get a reference to that editor. Let's get that editor's, let's find out what the editor is editing. It's editing a thing called HTML. Let's get the text out of the editor. Let's find out what the syntax coloring information is for that for the editor. Well, there is none because it's not in color, but let's tell it, well, color this as if it was XML. HTML is the same as XML as far as this is concerned. Now we can get some syntax coloring information. Now maybe you say, we now programmatically want to highlight our HTML tags in our edit window. So let's change the syntax coloring information. We can see that we have highlighted, it's not a very good algorithm, but it's highlighted the tags in our HTML. Let's create an HTML renderer, which shows us what that HTML might actually look like. We can get the position and size of our edit window. And if I move it around, we will see that its position changes. If I resize it, we can see that its size changes. So we can take, and we can close it. Okay. So we can take those bits and pieces of information that we've got, and what we'll do is we'll edit a name, we'll create a form underneath it with CodWC, and we'll create an HTML renderer. So we'll do that. Okay, so there's our form containing our HTML underneath our editor. What's the NC of on configure in an editor? Okay, well, now I noticed this the other day. It shouldn't be 0. Let's imagine that that returned a non-zero value. Let's create a function called report. Let's associate that report function with the configure event on our editor. So now as I move the editor around, we get configure events. So let's have a simple callback that intercepts that configure event. Let's associate that with our editor. So now when we move our edit window, our CodWC form moves with it. We can resize that, and those configure events are doing that. There's an on-change event on the editor. Okay, so let's report that. What's going on here? That's not right, is it? Hold on. Things have gone awry. Here's an editor. Blob on change gets, what was it, report, wasn't it? Hopefully now, when I make changes to the editor, we get a callback. Okay. Let's have a simple, now you see. Right, so let's just have a simple callback, which When the text in the editor changes, we update the text in the HTML window that's underneath. So let's do that. So now when I make changes, you know what, never do a live demo. There you go, right, so now when we make changes to our editor, the HTML changes underneath us on the fly, which is pretty cool. We can do. Okay, so that's kind of nice. So let's kick this in with a slightly better example, or a slightly more complicated example. In this workspace, I've got 33,000 lines or characters of HTML. First 1,000 of them look like that. Let's edit those. We can move this thing around. Okay, we can resize that. We can resize this independently. We can come over here. We don't like the word. Where are we? We don't like the word standardized. Let's just change that to test scores. Let's make sure we maintain the syntax of our. Oh, it's not that one, it's that one. Okay, this is a little bit slow. Look, if I type this, it takes a while to catch up. Actually, that slowness is because of the syntax editing in the editor. If I take that out, this keeps up very quickly with my typing. Okay, so what we've done there is, with the theory of everything, we have, with a simple function and two trivial callbacks, we've extended the built-in editor in APL in a way to do something very, very useful, but that may be very specific to what we want. And this is a way that maybe we can open up the IDE to our users to extend it as they will. And we don't have to do anything. We can give you the tools to do what you like, and you can play with it. This may or may not be a good idea. This doesn't necessarily map very well to RIDE, but it's an example of, if we have this internal object model, we can open up all sorts of bits and pieces to it. 2 minutes left. Right, so what if? So I realize I'm rattling through that. I would have liked another 20 minutes, but this is the first time, and quite possibly the last time, I'm going to do this presentation, and this is what happens. So if we accept then, and that's a big question, that there is this internal object model inside the interpreter, there is things that the interpreter knows about that hook in tightly to elements of the interpreter and your program, then maybe we can bring that stuff back a little bit into the language. Something that's always surprised me about APL is the behavior of, or the syntax of quadf create. Okay. For example, if I want to create a file and tie it, I have to specify a file name and a tie number. Generally, certainly in my own use these days, I always specify a tie number of 0. Okay, and then the interpreter will allocate a tie number for me and return it. And then I can append things to that file, and then I can untie it and so on. But, and we can write complicated, more complicated than we would like, single line functions that append an item to a component file. And read items from a component file. If this expression worked and returned something, then we don't need to pass that 0 anymore. Unfortunately, this generates a syntax error because quadf tie requires a left argument. But let's imagine if it didn't and it just returned a result. That would be nice. And if we could then read things from that and untie that, that's nice, because our expression then to append something becomes that, because we don't need any parens or anything. And then all we need to do is untie f and everything's good. Let's do that again. Quadf size of f. What might f be at this point? Well, if f is one of these internal objects that the interpreter knows about, okay, we've still got a file tie number, but the interesting thing is that f has got a property which is that tie number. And the cool thing about this is because the interpreter knows what that object is, when it goes out of scope, the interpreter can do clever things, like, for example, untie the file. Okay, which means that we can now append an item to a file with no need for any tie numbers at all, and we'll untie it as everything goes out of scope and all the ref counts drop. Now, this might be, well, this is certainly a simpler expression than the previous one, to just append an array to a file in a single shot. Okay. Quite how realistic it is, I don't know. I'm not really an APL programmer, so I don't know how many of you, keep files open for a long period of time. But a lot of expressions get a lot easier if, if we have a way of, if we have these internal objects. All of this stuff is happening without there being a file type staying open. Here's another example. So this returns an object, which is a component file, which has a member in its internal object model, which it calls quad f size, essentially. So we can do that. Is it a good idea? I'm not sure, but it's a theory of everything, and we're doing, it's certainly, whether it's useful or not, it's certainly part of everything. All of this stuff is happening without leaving any file ties behind, and we can throw the file away at the end. This would apply to component files, native files, or anything else perhaps in the language. Now, I have to stop. I realize I've rattled through it, but I think I wanted to get to that stuff at the end. But just to summarize in 10 seconds, because we have to leave. The theory of everything is this blob that allows you to put anything to the left of the blob and other stuff to the right, and we can use that consistent syntax and that consistent mechanism then to pretty much do anything we like. It's not necessarily a replacement for system variables and system functions, but it's an alternative. It's a way for us to do lots of things in a consistent fashion. I'm reasonably sure it's a good idea. I'm not convinced yet. There's a lot of things in the air, there's a lot of questions that haven't been answered yet. But, and I'm not going to be able to take those questions now, but obviously come and talk to me, come and talk to anybody else over the week. It's an idea, it's a thought, it's a theory. It may or may not be a good one. Thank you for your time. But we do now have to go and get lunch because we need to go and see that boat thing. Thank you.